flow control because it's a very simple protocol. So we will not be having any flow or error control in this protocol. Okay, so we are talking about one of the protocol, that is simple protocol. Now let us consider, we assume that I have a sender here or a transmitter, fine, and this is the receiver. Okay, so we assume that the receiver, okay, is he can like never be what you can say overwhelmed, okay, because a transmitter without asking, without knowing the situation of a receiver, okay, he keeps on sending the packets thinking that he can handle, that means the receiver can handle any packet it receives. Okay, so in other words we can tell that the receiver can never, okay, it is never overwhelmed. Okay, what happens, this is on, this transistor is on. That means transmitter, whenever he receives a packet from its upper layer, okay, so he just throw it to the receiver, assuming the receiver is anytime free and he can handle any number of packets. Okay, so if I just try to analyze in terms of application layer of sender and the transport layer of sender, okay, application layer, whenever he is having any packet to the packet to send, okay, he'll forward it to the transport layer, and the transport layer will forward through the logical channel to the transport layer of your receiver. Okay, irrespective of asking or requesting that the transport layer of receiver is busy or any any what you can say, busy or like free. Okay, so irrespective of any other options, okay, transport layer keeps sending the messages or packets to the receiver. Okay, so I think better understanding of this simple protocol we can do it using the FSM, right? Normally any analysis of a network we try to better understand using the FSM, right? So if we try to write the FSM of this, we'll be having two states. Normally will FSMs are written basically at two different sites, because we have sender site and we have a receiver site, right? So with respect to the sender site and receiver site, we'll write two different FSM for the simple protocol. At the stage of yes, your pulse match, you have an inverter. So one is then what will be the output of the inverter? Yes, who is that? So please notice, when your clock is high, your pulse logic is also zero still. It is still zero. Then when it is zero also, it is zero. So we are writing the FSM. Now let us consider, okay, the sender side FSM. I'll write the FSM here. Initially it will be in the ready state, okay, and this is the start, arrow mark indicates the start, okay, and whenever okay, so here based on the request came from the application, okay, what it does, the transport layer, it will make a packet, okay, and send it, right? So we are writing this is the FSM for sender side, okay. At the receiver end, if I try to analyze, okay, initially it will be in the ready state, okay, we'll have a start, fine, and the loop is given in such a way that whenever there is a packet is arrived, okay, so what it should do, it should deliver it to the process, right? Process in the sense the respective application, Okay, so if we see that this is the FSM at the receiver side. Okay, see what we are trying to tell in this case is the sender side. Okay, he should not send a packet until the application layer has a message to send, right? So I should get a request from the application. Okay, after receiving a request from the application, right? So the transport layer should make a packet of, I mean, whatever the information is received, it should segment it, make a packet of it, and it should send. Okay, so that start is basically we are talking the initialization or the ready state is will be activated. Okay, whenever there is a packet of information or the information received from the application layer. Okay, so the sending machine, it remains in the steady state until a request comes from the process, right? That means the from the application layer till, I mean, it will be in the ready state only, right? Why? Because it until it receives any information from the application layer, it will be in the ready state itself. So whenever there is an event occurring, that means whenever there is a packet which is being received from the application layer, okay, the sending machine tries to what you can say, encapsulate, okay, encapsulate the message in the form of a packet and sends it to the receiving machine. Okay, now what is the receiving machine should do? The receiving machine, it initially it will be in the ready state, okay, until any packet is arrived to the transport layer. Okay, so whenever a packet is arrived, when this event occurs, okay, then the receiving machine decapsulates the information, then it delivers it to the upper layer. Okay, so the information is delivered to the upper layer, or we can call it as the application layer. Okay, so this is a simple FSM for a general protocol which we are discussing, that is a simple protocol. Fine. So simple protocol is clear. So here there is no flow control, there is no error control. Okay, and assuming that the receiver is always ready. Okay, he transport, transmitter always assumes that the receiver is anytime free and he is not having any what you can say, the congestion or any buffer is not filled, so his capacity, nothing, he'll be aware of it. Okay, he'll keeps on sending the information to the receiver without even thinking about the receiver. The sender will keeps on sending the information whenever the sender receives the information. Is it clear? Okay.
Yes,
So for
ma'am.
this, yes. Yeah, for the same, we can write the flow diagram as well. Okay. So flow diagram for the simple protocol. So how can we show the flow diagram is, if I take, this is the sender side, okay, and this is the receiver side. Okay, here I'll be having a client process at the application layer. Okay, and I'll be having the client transport layer, right? Similarly, we'll be having one server transport layer and server process, right? So what happens is, whenever there is an now we will write with respect to the time. Okay, so think that a request is sent to the transport layer. Okay, now this request from the application layer is sent to the transport layer. From then the transport layer makes a packet and sends it to the destination. So what we are sending? We are sending a packet. Okay, and that will be decapsulated and it is arrived to the server process. Okay, so similarly this happens. Okay, irrespective of any other control. Right? So it is a very basic and a simple protocol, right? Okay. The next protocol what we are having is the stop and wait protocol, right? So let us talk about stop and wait protocol. Okay, so here it is a connection oriented protocol. Okay, so we'll write it is a stop and wait protocol is a connection oriented protocol. Okay, and it uses both flow control and error control. Okay, because in the earlier case we saw that it did not have any flow or error control, and it assumes that receiver is anytime free to receive the packets, right? But here in this case it makes use of both flow and error control. Okay, and here both the sender, okay, as well as the receiver, they use a sliding window. I'll tell you what it is. Okay, they use the sliding window of size. Okay, window size. I'll just give it as some letter L. Okay, and here what happens is sender he sends one packet at a time. Okay, and waits for an acknowledgement before sending the next packet. Okay, so what happens is like as we know that if I have 1 2 3 some packets like this, okay, at the sender end, and the first packet is sent to the, okay, I'll write transmitter and receiver. First packet is sent to the destination. Okay, if acknowledgement is received, then only the second packet is sent to the destination, right? So if there is no acknowledgement, whenever no acknowledgement, then the next packet, okay, will not be sent, right? No packets are sent. Okay, now when the packet arrives at the receiver side, okay, it will check the packet will be like checked. Okay, so if at all the checksum is incorrect, now consider, if at all the checksum is incorrect, okay, then the packet is considered to be corrupted. Okay, and it will silently, it will discard it. The packet is discarded. Okay, and here what happens is the receiver will discard the packet silently. Okay, this silence of this receiver, okay, is basically a hint for the sender. Okay, that means it is.
Ma'am, you're muted, ma'am.
uh, is it muted now or from the beginning?
It was muted now, ma'am.
Okay, okay, wait.
Now reset, different types of reset. One is synchronous reset and another one is asynchronous reset. Asynchronous start of the clock. Synchronous is the clock. So that is the first difference. Next, synchronous indicate clock and wait. So
Okay.
and reset is direct.
So what happens in this case is, with respect to stop and wait protocol, okay, yeah, we know that the first packet is sent, and until any acknowledgement is received, second packet will not be sent, right? Here, whenever a packet is received at the receiver end, okay, so receiver will go for checking of the packet using the checksum, right? If the checksum is incorrect, okay, the packet will be I mean, in case if it is corrupted and it is incorrect, okay, the packet will be silently discarded by the receiver. Now, what happens? Receiver will keep quiet. Okay, I mean, he'll be very silent. Okay, the silence of the receiver is an hint or an what you can say it is a signal for the signal for whom? It's a signal for the sender. Okay, the sender will analyze that. Okay, I mean because he will start a timer, right? The sender will start a timer whenever he sends the packet to the receiver. So when the timer gets expired, okay, or it expires, then what happens? Before the timer gets expired, if at all it did not receive any acknowledgement, okay, then the sender he has to retransmit. Okay, he has to resend the packet, thinking that the receiver is silent. Then sender will assumes that the packet is either lost or it might be corrupted. Okay, so the sender will keep a copy of the packet until the acknowledgement is received, right? So this is how the stop and wait protocol basically works. Okay, so if we try to write the stop and wait protocol, okay, so consider that we have a sender, okay, and this is the application layer and this is the transport layer, right? We have a process here and this is the sender, right? And what it does here at the transport layer, tries to add the header. Okay, it frames packet. Okay, so initially what it does, it will send the information or the packet, right? So the packet will be given a sequence number, right? So I'll write sequence number yes. Okay, and okay, this is, let me call this is my packet. Okay, so the packet will be having even the checksum also. See, this is a sequence number and this is a checksum. Okay, now what happens is through the channel, okay, it will be sent, right? Now it's sent to the destination, right? So this is my receiver and receiver also has the respective layers. Okay, so what happens is the packet will be arrived. Okay, if the checksum is matched, okay, then checksum as well as your sequence number which is received, okay, it's the same along with your data. Okay, if the checksum is matched, it will transmit the packet to the upper layer. Okay, then immediately he will send an acknowledgement packet. Okay, so it comprises of acknowledgement number and the checksum. Okay, so that will be sent to the sender. Fine. In case if the packet is corrupted, okay, so receiver what it does, he will keep quiet. Okay, for he will discard the packet and he'll be silent. Okay, so in that case, fine, so if the timer is off, okay, and sender has to retransmit the same frame. Okay, so that process happens for, okay, let us show the timer part here. Okay, for a specific duration of time, initially when it sends, okay, the timer will be on. Okay, so within the stipulated timer, timer will be there at both transmitter and the receiver end. Okay, so if at all this is a timer for the next packet to receive. Okay, and this is the timer for the packet which you have sent, right? So both the timers will be on. Okay, so once the first packet is received and it is acknowledged, the receiver will wait for the next packet and he will on the timer. Okay, so in case if it is not, then he may try to sent or acknowledge the receiver that is there, because he might have not sent the whether the information is a last byte or last packet. Okay, so that information might have been known by the receiver such that the timer will be on in order to receive the next packet. Okay, so here in case if the packet does not arrives, then possibility of receiver asking the sender, is there any more packets to be received? Okay, so that is through the logical channels which will be created between the transmitter and the sender, right?
What do you mean by that? Now then, so I told you, whenever you have timing, there are two features. Number one, it incorporates the camera. Next, number two, there is a capacity.
Now let us understand this with respect to a FSM. Okay, so the FSM of the stop and wait protocol will be written something like this.
So what exactly is the intention? See how many slides.
Hold on for a second. Right. So you can see this FSM, right? So here, this is the FSM where the FSM for it can even apply to stop and wait protocol, right? Okay. So here, what happens is the protocol. What we are talking is like stop and wait protocol is a connection-oriented protocol. Okay. So both the ends should be now. Initially, it will be in the established state. You can see here. Okay. This is for connectionless transport layer. Okay, and here you can see this is for the connection oriented. Okay, so this is the FSM which we are discussing now. Initially it will be in the established state. Okay, both we are talking about the sender and the destination. Okay, so it will initially it will be in the established state. Okay, before exchanging any data packets. Okay, now the states are actually here you can see it is in the form of a nested. Okay, nested established state, right? So at the sender end what happens is sender is initially he will be in the ready state. Okay, and like he can move the packets or he can move between the ready state and a block state, right? Block state where basically he'll be you can see that there is a closed here, right? Initially either be it'll be in the established state or it'll be in the closed or like block state. Okay, so whenever we think that he is in the ready state, right, that the sender is in the ready state, he is waiting for one of the event to occur. Okay, some event should occur, right? So for that he'll be waiting. If a request he receives from the application layer, okay, then the sender he creates a packet Okay, and that packet comprises of a sequence number to the, I mean, sequence number, you can call it as some thousand or something like that. Okay, random sequence number will be generated, and that sequence number will be added to your packet, and a copy of packet will be stored. Okay, a sender who he will store the copy of a packet in the buffer. Okay, and then the packet will be sent. The sender, when he sends the packet, he will start the timer, right? So in that situation, I mean, when he starts the timer, right, because sender will send the packet, he will start the timer, then he'll go to the block state. Okay, see, I'm talking about something called as, you have ready state and you have a block state. Okay, so in this ready state and block state, no, sender will send the packet. Okay, initially before he receives the packet or before he sends the packet, he'll be in the ready state, right? After the packet is received, okay, he will take the packet, he'll encapsulate it. Okay, then he will send the packet by storing the packet in its buffer. Okay, and after he sends the packet, he will start the timer, right? And he will, sender will enter into the second, that is called as block state. Okay, so in block state, what happens in this, like basically three events will occur. Okay, so three events, what are those? First event is like, if an error free acknowledgement arrives. Okay, that means within the timer acknowledgement is received. Okay, so in that situation, I may have to discard what the packet whichever is been stored in the buffer. Okay, then going, I mean, you have to send, sender has to send the next packet. Okay, second thing, if at all he receives a corrupted acknowledgement. Okay, so corrupted acknowledgement, in that situation, what may have to think, again the acknowledgement is discarded at the sender side. Okay, and he will intimate the receiver that the acknowledgement whatever is received is not correct. Okay, third case is like, in case if any timer expires. Okay, so timer out happens, fine. So then sender has to resend the packet. Okay, the same thing is replicated here. Okay, you can see here. So established state, okay, a connection phase, connection close request accepted from the application layer. Okay, first you are sending a the blue colors and the black colors are the two different operations. You can see, send a close request packet at the other end. So these are the two things happening in two different situations, right? First, data transfer occurs after, initially it will be in the ready state or established state. Data transfer occurs when both ends are in the established state. Okay, then it has to create a connection, right? So you ask for the connection request. Okay, so connection request is accepted from the application. Okay, and for that acknowledgement is received from the other end. Okay, here then a close request packet arrived from the other end. After receiving a packet, what it has to do, you are going to send an open request packet to the other end. Okay, for which you will receive, after you send, then you have to wait, do nothing. Okay, then at the receiver end, probably you may have to send the acknowledgement. Okay, so depending on the process, okay, it takes up the respective event, right? So initially, as I told you, the sender and the receiver, both FSM is shown here. So that is why the content may be like, you may get a little confused here in order to analyze, because for depending on the event it has to react. Okay,
Anybody else who are not able to give the attendance?
so I'll continue this in the next class. Okay,
The owners and taker is also considered.
let me take up the attendance.
Okay, students. So let me finish any report.